Welcome to the tips and tricks of chemistry. Today we are going to learn about the very important topic, that is factors that stabilizes the negative charge in the organic chemistry. By using these factors, you can also compare the stability of carb anions. Let's see the factors one by one. The first factor is the lesser the charges, the better the stability is. Here we have taken the comparison of oxygen. Here, in this case, the oxygen is having the -2 charge. Here, the oxygen is having -1 charge. Here, the oxygen doesn't have any charge. So, you have to remember when you are comparing the same kind of atoms, the atom carrying the lesser charge will be the most stable one. Let's see the another factor. As you know that when you are going in the period from left hand side to right hand side, the size decreases. It means when the size decreases, the electronegative character increases. So the more electronegative atom is capable of carrying the negative charge better. So the one which is more electronegative will carry the negative charge better. So that particular atom will be more stable. So let's see the example. Uh, Here the carbon is carrying the negative charge. Here nitrogen is carrying the negative charge, that is from group 15. Here oxygen is carrying the negative charge, that is from group 16. And the fluorine is carrying the negative charge, that is from the group 17. As you know that the most electronegative atom is fluorine. So it is highly stable than oxygen. And oxygen one will be more stable than nitrogen. And nitrogen one will be more stable than the carbon one. Let's see the next one. Here in this case, as you can see, it is again Cl is from 17 group, that will be more stable. Uh, this uh, this is sulfur, which is from the 16th group. Phosphorus is again from the 15th group. So the sulfur one will be more stable than the phosphorus one. The factor. This factor is very useful when you are dealing with the atom carrying the negative charge from the same group. As you all know that when you move down the group, the size of the atom increases and it become more polarizable. So the one which is having the higher size will be more polarizable, and it will be able to carry the negative charge better. So as you move down the group, the stability of the negative charge increases. So that's the reason iodine will be more stable than the bromine anion, and the bromine anion will be more stable than the chlorine anion, and the chlorine anion is more stable than the fluorine anion. This is again from the 16th group. As you move down the group, the size increases, polarizability increases, the stability on that particular ion, the one which is in the bigger size, will be more. So here in this case, the polarizability is more, so it can carry the negative charge better than this one, and this one can carry the negative charge better than this one because of the size difference. Let's talk about the fourth factor. In this particular case, the negative charge is stabilized by the resonance. Means higher the delocalization, higher will be the stability. Means it is totally depending upon the number of resonating structure. Higher the number of resonating structures, higher will be the stability. As you can see that the first one is less stable because it doesn't have any resonating structure. In the second one, when the electron moves over here, the double bond electron will shift here and forms a negative charge, means it can make one resonating structure. In this case, the electron can move here also and here also because it is in conjugation with both the double bond. So it can make two resonating structure. This one can make one resonating structure, and this will not make any resonating structures. So the one which is making the higher resonating structure will be more stable than the one which is making the less resonating structures. Let's talk about the fifth factor. Here we have taken the example of carb anion, As you all know that carbanion is an electron rich species. So if you are talking about the inductive effect, the group which is donating the electron will make that carbanion very unstable. So here the electron withdrawing group will stabilize the stability of the carbanion. So in this particular case, you have to see that here there is no electron withdrawing group. Here there is one electron withdrawing group which is increasing the stability of this carbanion. Here there are two electron withdrawing groups which is increasing the stability. Here three electron withdrawing groups, that is chlorine, which is increasing the stability of this particular carbon. So this one which will be more stable because there are three electron withdrawing group attached to the carbanion. Here it will be less stable than this and more stable than this two. Let's talk about the sixth factor. The sixth factor is all about the hybridization. That is all about the S character. You have to understand that the anion stability is more when the S character is more. So the higher the S character, higher will be the stability. It means the singly bonded will have the lesser S character, doubly bonded will be having the some more S character, and the triply bonded will have the highest S character, which makes the carbanion more stronger and stable than the sp2 hybridized and the sp3 hybridized one. Let's talk about the last factor. There's a special case where the negative charge is more stable when it is a part of the aromatic system. Here, in this case, this particular molecule is not an aromatic compound, so it is very unstable. Then this particular one, as it is being an aromatic compound having 6 electron, which is following the 4n plus 2 rule, that is Huckel's rule. This particular compound is 10 raised to 33 times more stable than the molecule on the left.